All right, so what are we ultimately trying to find? The height. So talk to me about height. What do we always know about the height of something? It's not necessarily a math answer. It's like a common sense thing. If I asked you to measure my height, how would I have to, what would my orientation be? How would I have to be? I'd be standing straight up. So height is always vertical. What do we know about the ground? It's always horizontal. So what do a horizontal and a vertical line make at the bottom? A right angle. Very good. Anytime it asks you how tall something is or for the height of it, if it doesn't say it's tilted, you assume, and this is okay to assume, that it is straight up and down. It's vertical, which means it should make a 90-degree angle with the ground. So to eventually find this height, I can use SOHCAHTOA. I said eventually, right? So look at your two right triangles. I'm going to zoom this in now because we've gotten all of our information. If you look at your two right triangles, you don't know any of the side lengths of the right triangles. Some of you did this last night on your homework. What's wrong with that? Yeah, you don't know that the height is right in the middle of those two people. It probably shouldn't be if one of them's having to look up at 44 and the other one only has to look up at 38, right? So you do not know that that height cuts 320 in half. You don't know that it's a mid-segment. Do we remember that word from math too? Okay, good. So what can I do? Okay, good, Dre. What's the top angle? 98 degrees. Did you guys get 98 degrees for the top angle? All right, so look, if I use that 98 degrees and do sine of 98 over 320, I can use one of these angles to find one of my sides, correct? Okay, so watch what happens if we know one of our sides. If I know this side length and I know this angle, could I then use right triangle trig, SOHCAHTOA, to find the height? Yes, but you have to use law of sines first because they didn't give you enough information to just do SOHCAHTOA. So we can do sine of 98 over 320 equals, which side do y'all want to find? It doesn't matter. Okay, I can use 44, that's fine. So sine of 44 over, are you guys okay if I just call this side x? Okay? So then what do I do from there? Cross multiply. If you used the 38, stay using the 38 because you're going to see you're going to get the same thing we get, okay? Cross multiply, so that would be x times the sine of 98 equals 320 times the sine of 44, right? And then what would I divide to get x by itself? Sine of 98. So I'm going to go to my calculator. You can also use Desmos. I actually recommend using Desmos. I just don't want to have to flip my screen. And I'm going to type in 320 sine of 44 divided by sine of 98. Oh, I'm not, look at that. What did I not do? Good, I didn't put it in degrees because I got a negative. Perfect. Because I'm not using the same calculator from yesterday. Let's try again. 320 sine of 44 divided by sine of 98. All right, did you guys get 224.48? Now, Kendall's not up here, but I do want to talk about what Kendall said yesterday. You should not round this value. If I round this to 224.48, then my final answer for the height is probably going to be a little bit off. So who remembers from unit 3 and 4 what I can do with this value so I don't have to round it? Good, girl. Store as X. If you're using Desmos, you can copy and paste it, okay? So I'm going to store this as X. So just as a review on a calculator, if you hit this STO button down here and then you hit the X button right here. Now I have this number in for X. So whenever I want to use that number, I can just hit the X button in the calculator, okay? Again, in Desmos, you can just copy and paste. So now we know that this piece right here is around 224.48, right? I'm going to stop and let people ask me questions while I get a sheet of paper to finish. Yes. Yep. Yep. So if you don't want to round, you also don't even have to find this number out yet. You could just do like write X as 320 sine 44 over the sine of 98. I don't like leaving it like that because I don't normally have the capability of opening multiple windows. So I usually type it in. But yes, you could leave it just like that for right now. All right, so I want everybody to look at what I'm going to do with this piece right here. Shift. I have a right triangle now. We don't know the bottom piece because the whole thing is 320, not just this one piece. But I do know this angle is 38 degrees. And I now know this side that I stored for X, right? So can we find the height now? Yes, you can use SOHCAHTOA. So look at what we want. What side do I want? Opposite, adjacent, or hypotenuse? We want the opposite. We have the hypotenuse. So what trig function can I use to solve? Sine, good. Opposite over hypotenuse. So sine of 38 equals the opposite. We don't know, that's the height. The hypotenuse, we do know that's what we just stored as X, right? That 224.48. Are y'all okay? Some of y'all look really lost. I'm gonna be 100% honest with you. This is math too. So if you're lost about something, I really need you to ask me. Because I feel like we should be fine with this stuff. So if you're not, ask me a question. How do you get H by itself? And good, multiply by the 224.48, and I'm just using the X because we don't want to round it yet, right? So in my calculator, I'm going to hit X sine of 38 degrees because I just stored that 224 as X. So X sine of 38. So the height is 138.2 feet. Are we okay with that warm up? I'll move this over a little bit so people at home can see. What questions do we have?
Can we use the other side as well?
You can use the other side, you'll get the same thing. So if you used the other side from the very beginning, you do sine of 98 over 320 equals sine of 38 over X. You would solve that, get whatever this side would be, store it, and then you would still do sine, but because it's with a different angle, you'd end up with the exact same answer for that height. Good question. There's always, like every year that I've taught pre-cal, when I took pre-cal, always a problem just like this on the exam. Yes. That's okay. As long as you have the steps we talked about yesterday, I'm good. Maybe. I'd honestly have to see it. I can look at your homework in a second and let you know if that's okay. Okay? All right. People at home, any questions before we go over homework? Once going twice. All right, kiddos. Let's rock and roll. Law of cosines. This one is my favorite. This is the second and the last thing I will ask you to memorize in pre-cal. First thing was those Pythagorean identities. These law of cosine formulas, you will need to memorize one of them. but it makes a pattern. So if you're good at recognizing patterns, you actually, it's not really memorization. Okay? Page 41, law of cosines. This should not take too long. Like I'm banking on 20 minutes. Oh. So review from yesterday. What information do we have to be given to have to use the law of cosines to solve? Two sides and one angle or
3 sides.
3 sides. Very good. So 2 sides and an angle or 3 sides. So law of cosines. We have to use this to solve an oblique triangle. When given side, angle, side, or side, side, side. You should not be given ASS, just to make sure we're all on the same page. All right, so let's go ahead and write down what the law of cosines is. I'm just going to write it and have your copy, and then we'll talk about it. So law of cosine states that for a triangle with sides ABC and opposite angles alpha, beta, gamma, C squared equals A squared plus B squared minus 2 times A times B cosine of gamma, or so cosine of the C angle. What if we're not trying to find C squared? What if we want A squared? Can you guys tell me, looking at the pattern, what you think the formula would be? B squared plus C squared, very good. Minus, be careful, we want A. 2BC cosine, what angle would go here? The A angle, good, because you're trying to find A. It's just a pattern. All right, can you guys come up with the formula if we wanted to find B? Follow the pattern. What do you think it would be? B squared equals what?
A squared plus C squared.
Good.
2AC.
Good.
Line of Alpha or
Beta, because you want B. Good though. It is just a pattern. Do you think Miss Poole memorizes all three of these? Nope. Pick one. So what did you guys think when you first saw the beginning of the first one? What's it kind of look like? Pythagorean theorem. It actually comes from Pythagorean theorem. So I'm going to draw you a picture quickly. I'm not going to spend time showing you this now. If you want to see where it comes from, come to office hours. If you have a right triangle, does everybody agree a squared plus b squared equals c squared? Okay? We don't have a right triangle anymore. Typically, these triangles are acute. So I just moved this in. So we did a squared plus b squared, but then we got to subtract, because we're making it smaller, 2 times a times b times the cosine of this C angle, because this is the one that I moved. That's the one that's no longer a right angle. You want to see more where it actually comes from and like see the proof on it? Come to office hours. I can also put a video up. That's basically where it comes from. It does come from Pythagorean theorem. It's just no longer a right triangle. So whatever side you want to find, you add the squares of the other two, subtract 2 times the other two, and then take the cosine of the angle that matches that side. It's just a pattern. Pick one, know the pattern, and then you should be able to do it for any example, okay? I haven't asked you to memorize anything this year except for those Pythagorean IDs and then one of these. It shouldn't be too bad. Now, these are used if we're trying to find a side. Because look at what's on the side of your equals. C, A, and B, those are all sides, right? Yes? Okay. How do you guys think we could find the angles? What if we wanted gamma, alpha, or beta? What do you guys think we could do? Okay, so gamma equals, alpha equals, beta equals. Only problem with that, they're attached to the cosine. So when you're trying to find the angles, they'll say cosine of gamma equals, cosine of alpha equals, cosine of beta equals. Is everybody okay with that? There are 3 formulas for finding angles. I like to memorize one of those as well because it's also just a pattern. I want to show y'all, though, if it's okay, where those come from so you understand why we get that formula, okay? Because those don't take long. So let's take this first one. C squared equals a squared plus b squared minus 2ab cosine, and you can just say cosine of c, that's fine with me. I want to show y'all how we get cosine of gamma by itself to find the angle if we're missing an angle, if they ask us for an angle, okay? All right, so if I want cosine of gamma by itself, I'm going to cover it up, right? What should I move first? Okay, be careful. The 2ab is also attached to the cosine gamma. So what should I move first? A squared and b squared. How would you move positive a squared? Subtract it. How would you move positive b squared? Subtract it. So are you guys okay if I subtract them both at the same time? Where I'm just showing you where the angle formula will come from. So this will be c squared minus a squared minus b squared equals negative 2ab cosine of gamma. Now to get cosine gamma by itself, what would I move? Am I going too fast? I see a lot of y'all looking around flustered. Are we okay? I'm just showing you how we would get an angle formula. Nat, you look flustered. You okay? All right, if I want cosine of gamma, how would I move the negative 2ab? Divide it. Very good. So look, we're going to divide negative 2ab over, and it'll go away over here. So only thing your formula does from here is they get rid of the negative. Does that make sense? So they don't divide by the negative, they actually put the negative in the numerator, which is fine. What's a positive divided by a negative? A negative. So what your formula does is it puts the negative up top. Exactly. It changes the signs of everything up top. So now it's positive a squared plus b squared minus c squared over 2ab. That's how you find angle C. This formula right here. So I was just showing you where it was coming from. Do you need to know that? No, but every year I have a kid ask me. So that's why I say you don't have to know your angle formulas. You could work backwards every single time to find the angles, but that's a lot of work. Do y'all agree or no? I'm worried because some of y'all look really stressed. No, girl, I don't want you to work backwards every single time to find the angle. I would like for you to learn one of these. Exactly. Good. So that's why I said I like these, because I'm good at recognizing patterns. It's just a pattern. So what Mary just said, if we wanted to find angle B, you add the other two. So I would add a squared and c squared, subtract the angle that matches over 2 times the 2 you know. So 2ac. It's just a pattern. David Day and Riley Morris loved this section. They're like, bro, it's just patterns. Those boys are funny. So then the third one, if we wanted angle A, what could I do? Good, Ross. B squared plus C squared. Keep going, bud. Yep. Excellent. Over 2BC. Sorry, I ran out of room. These are the 3 angles you'll use if you're trying, or 3 formulas you'll use if you're trying to find angles. That's all of your notes for today. I just have 2 examples. It's really just practicing with the patterns, making sure you know them. Huh? The third one, cosine of A. Sorry, can you see it now? B squared plus C squared minus A squared over 2BC. How do we feel? I feel like we just need to see an example and practice. I didn't even tell you all the best part. Once you find one of the angles or find one of the sides, then you can set up proportions. So these are easier. Use a formula, find something else, and then you should be able to use law of sines and set up proportions. Okay? Questions? People at home, questions you have for me on these 3, I lied, 6 formulas? Nobody? All right, let's do a couple examples and then I'm going to give y'all homework time, because you really just need to practice. So example 1, we want to solve this triangle. I'm going to give you a picture for the first one and then you'll have to draw the picture for the second. Sound good? Great. I love talking to myself. Fantastic. All right, listen to me very carefully. On your test, all the triangles are intermixed together. There's some right triangles. There's some triangles where I gave you angle, side, angle. There's some where I gave you side, angle, side. You have to know when to use what law. Okay? You cannot use law of sines for this, even if you tried. I want you to look at why. Sine of 40, do we know what that goes over? Nope, but then you also don't know what the angles are to match these two sides. So that's why we can't set up proportions yet. That's why if you're given side, angle, side, or side, 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 you can't do proportions. You don't have enough information. But what we can use is the law of cosines to then try to set up a proportion. So what would y'all like to find first?
Side
I would find A first. I'd find that side. I think that's the easiest option because it'd be hard to find an angle first because you're missing two. Does everybody agree with that? Okay, don't flip back. Let's remember our formula for finding A squared. Don't flip back. Natalie's like, I don't have to flip, I write small. Don't look at it. How could we find A squared? Pythagorean theorem, what would we do? B squared plus C squared minus, because it's not a right triangle, 2BC, good, that's what you know, cosine of angle A, because you also know that. So now let's just plug in. Once y'all write it, I'll give you a second. All right, so now I'm just going to plug in. I don't know A. That's what I'm trying to find. What's B squared, y'all? 3 squared, which would be 9. If you want to go ahead and write 9, that's fine. What's C squared? 16, or you could write 4 squared because we're going to go put this in Desmos. Minus 2 times 3 times 4 cosine, what's angle A? 40 degrees. Where do you think I go type this lovely thing? In the Desmos. Honestly, it's if you know the formula, it's a little bit easier than law of sines. You literally go put it straight into Desmos, okay? So I'm going to switch over to Desmos so I can show everyone how to type this in. Hopefully I have it open. I don't. I got my Christmas shopping open though. All right, 9 plus 16 minus. Did everybody see how I put parentheses? Because you need to multiply 2 times 3 times 4 times cosine 40 first, okay? 2 times 3 times 4 cosine of 40. All right, and then what mode do I need to make sure I'm in? Degree. So I'm going to go up here to my settings. I'm not in degrees, so it's a good thing I'm switching it. There's my degrees. All right, so what does this 6.61 equal? A squared, so how do you find just A? Very good, kiddos. Take the square root. Square root of 6.6149333, and I don't need to do anything else because this isn't changing. So A would be 2.57. Does everybody agree with that? Now listen to me. Can we round it yet? No. So this is where you would need to save this number up here, copy and paste, that kind of thing, okay? 6514. Put the whole thing up there. All right. Is everybody good with how we found A? Okay. People at home, I'm guessing yes. Y'all are not doing a good job participating.
Wait, how'd you get the 6.61?
I typed in 9 plus 16 minus 2 times 3 times 4 cosine 40.
And then did you copy it to like get the square root?
Miss Poole, why did you have to square root it again?
Because it says A squared, and we just want to find A.
Oh, okay.
Good question. Did y'all write down what it was? Can somebody tell me? 2.57, thanks, Ross. Approximately 2.57. Now, what other pieces are we missing? Okay, now you're missing some angles, good. And that's it, right? Just these two angles. But now look at your picture. Could I set up proportions now to find those angles? Yeah, so remember, once you're setting up proportions, what law are you now using? Good, sine. Once you can set up proportions, it's law of sines. So it's the same thing as yesterday. So is everybody okay if I do for the next part, sine of 40 over 2.57 equals, we don't know the other angle. Do y'all want to find beta? Is that okay with everybody? So I'm going to put sine of beta. But we do know side B is 3. Do you have to find beta? No, you could find angle C first, right? Doesn't matter. You just got to find everything that's missing when it says solve. All right, people at home, I need y'all to unmute and ask a question if you have one. I'm going to keep going because I don't hear anything. All right, what do I do now? Cross multiply, fantastic. 3 sine of 40 is what I heard from somebody else, equals 2.57 sine of beta. Now this is going to be the step that's different. How do you get beta by itself? Divide 2.57, good. Make sure I show all my work. And now, how do I get rid of the sine? It's the opposite of sine. No, I did not say, Lord Jesus. Kevin, I need you. These children saying cosecant. Did I ask what the reciprocal was?
Sine
The
inverse?
opposite of taking the sine. Thank you, Ann. I didn't hear you. Everybody else talking about some secant, cosecant. Ooh, sine inverse. Lord Jesus. Teaching is a struggle sometimes. So is learning. It's okay. We got it. Then you'll just take the sine inverse and that will give you what angle B is. So I'm going to let y'all write it and then we're going to go in Desmos and we're going to do it. Sound good? Okay. KJ's like, okay. This isn't bad. You just got to know one of those first formulas to find a missing piece and then you can set up proportions again. Okay? All right, I'm going to Desmos. I don't hear any objections. I'm going to type in sine inverse of 3 sine 40 divided by 2.57. So what is angle beta? Okay, what is that? Round it for me. 48 point what? Good. 48.62 degrees is what we get for angle beta. 48.62. I'm going back to my paper. People at home, if this is too fast, I need you to say something. Beta is 48.62 degrees. Good. So did you get something different? I'm so proud of you. What'd you get? Extra credit. 57. Perfect. This is a great teaching moment. Good job, Anne. I was so busy making fun of them for saying cosecant. What are you supposed to use instead of 2.57? The whole decimal, the stored value, the whole value you get right here for A. So do you see how it changed my answer? That's an excellent teaching moment. Extra credit. Make sure you do not put your rounded number in there. Do I need to check behind you or you're 100% sure that it's 48.57? She's like, it's 48.57. You're the one that messed up, not me. 48.57. That's what beta would be. Good job, Ann. So how would we find this last angle? Subtract it from 180. Perfect. Don't type that in a calculator. 57 cents. That means you need 43 more to make $1, right? Okay, so we know this one should be 0.43. And then let's see. 48 and 40 would make 88. But then I've already got my change, so 180 minus 87, 93. Nope. 92. Nope. I'm fussing at y'all not to use the calculator. 91 for real. I prefer you not use a calculator. We need to work on our mental math, me included. So this angle C would be 91.43 degrees. Do we feel like we can try one where we find the missing parts? Yeah? It is a lot. It's honestly not any more than what we did yesterday. Just yesterday was easy because they gave you 2 angles, so you could just subtract from 180 to find the third. And then yesterday you had to find 2 sides. Today you'll find 1 side or no sides, and then use one of your formulas, and then set up proportions for the rest. I'll put another one up here. My computer is about to die, so I need to write it really fast and grab, oh, I have my charger. Right on. Hey, kiddos. You're gonna solve, I don't know why I wrote example 1. Solve the triangle where A is 3, B is 5, and C is 7. I can help you get started if we need it. I want us to start here. Draw a picture. Should be an easy picture to draw. And I'm going to say it again. I can't see people at home. I can't see y'all's faces. So either we get it or I'm going too fast, or we don't get it. I'm not sure. We're really quiet. But my people in class, I can read y'all's faces. Some of y'all look lost. Ask a question. Because tomorrow I'm not doing more law of cosines. We're going straight into area and applications. So ask me questions if you have them while you're here. So how would you eventually move it? Good. All right. Mary's already setting hers up, so I'm going to join her. A is 3, B is 5. So that's angle A. This would be angle B because it has to match with side B. Are y'all following me? Okay. And then C is 7. So this would be angle C. So that's her picture she drew. And then what she just asked me was, okay, so we have to use our formula to find an angle. What angle do y'all want to find? Okay. Start with A, works for me, angle A. Let's try to remember our formula for an angle. It's just a pattern. So what do we do? Good, B squared plus C squared, not A, C squared, because that's what you know. Minus A squared, because that's what goes with the angle we're trying to find. Divided by 2BC, good. So what she asked me, I know y'all can plug the numbers in and put it in Desmos and be fine. What she asked me was at the end, what are we going to have to do to find just A? And then she answered her own question. What's the opposite of cosine? Don't you tell me secant. Cosine inverse. So to find the angle A, you're going to have to end up doing cosine inverse. You could go ahead and move the cosine inverse if you wanted and put it all in parentheses. Absolutely. So B squared, what would B squared be? Thank you. That took you a while. What's C squared? 49. What's A squared? minus 9 over 2 times B times C. You can type that whole thing in Desmos and it'll tell you what the angle is. And then to find the next angle, you can set up a proportion. So y'all go do it because some of y'all are looking at me really confused, but I don't know how to help you if you don't ask me a question. So I'm going to stop the recording for now. Let him get rid of that. So did y'all go to, just to show you what they were saying in class, if you're at home on a phone and you hit functions right here, there's a cosine inverse function that you can also hit. So they did 25 plus 49 minus 9 divided by, that didn't work. Put the whole thing in parentheses, maybe. Or you can do it like that. Over 2 times 5 times 7. Oh my gosh. 2 times 5 times 7. Here we go. Did y'all get 21.79 degrees? Awesome. So then what did you guys do? I'm going to write down 21.79. You can go ahead and round the angles. It won't mess anything up. Okay? All right, y'all aren't answering me again. Am I good to keep going? All right.
Yeah.
Okay, cool. Thanks, Kev. I don't know when y'all don't answer. Some of y'all low-key got turtle hands. From here, did y'all set up a proportion? Okay, let me ask you a question. Do you have to do a proportion? If you like these formulas, couldn't you just use another formula for the other two? Yeah, you could. I think a lot of you aren't fond of the formula, so you probably did a proportion. That's fine too. But you could do it either way. I'll do a proportion. That's fine. So sine of what we just got for alpha over side A is 3 equals, what do y'all want me to find, beta or gamma? Beta, you just like to go in alphabetical order. And then cross multiply. I feel like we could do that. So Mary, you want to tell me what you got for beta? Okay, 38.21 degrees. Look at my girls, extra credit. And then what y'all get for C? So how would we find C once we know beta and alpha? Good, add them up, subtract from 180. So what'd y'all get for this one right here? 125 degrees. Great work, y'all. Do we feel like we can do this on our homework? Oh, sorry, you said one, it sounded like you said 125.
I said flat.
120 flat.
So they're decimals.
What a weirdo. All right.